Welcome everyone to Macroeconomics, exercise class session 5, ISLA model, formal analysis. What we are going to see in this video is an expansionary monetary policy and an investment trap. For that, we are given on the question that the goods market and money market equilibrium are described in the below two equations. Remember, IS curve depicts the investment and saving function. It represents market of economic goods, and the curve depicts the relationship between interest rate, investment level, and output. So the first question in this problem 17 is to formally compute the slope of the IS curve. We have said that our IS curve is given by the formula y is equal to CO plus C1 multiplied by y minus t plus BO plus B1y minus B2I plus government expenditure. As we have been doing in the previous exercise sessions, we would first get rid of the bracket in the right hand side, C1 multiplied by T plus our BO plus B1Y minus B2I plus G. And then we would gather the Y terms to the left hand side by subtracting these two items from our right hand side. So this would give us y minus C1y minus B1y would be equal to C0 minus C1t plus BO minus B2I plus government expenditure G. If I take y as a common, I would have 1 minus C1 minus B1, which would give me again the similar equation on the right hand side. And I would divide both sides by 1 minus C1 minus B1, 1 minus C1 minus B1, which can be simplified and written as y is equal to 1 over 1 minus C1 minus B1 multiplied by CO minus C1t plus B0 minus B2I plus G, our government expenditure. Again, to calculate the slope of our IS curve, we would take the total differential of our equation. When y take the total differential, we would have dy on the left hand side. We would have our term 1 minus C1 minus B1, and in the bracket we would have dCO minus C1 multiplied by dt plus dBO minus B2 di plus dg. So after taking our total differential, in this case, what we want to do is we want to derive the slope of our IS curve, which is actually represented by the formula di over dy. If you remember, on our ISLM representation, I was on the y-axis, while y was on the x-axis. So to calculate a slope of a line, we usually do the change of our y with respect to our x. So that is to say, for our IS curve, we are calculating the change of our I, di, with respect to our x, which is dy in this case. Another assumption before we go ahead is we are setting the terms dC0 is equal to dt is equal to dBO is equal to dG. All of these terms should be set to be equal to 0 because we are not informed about their change. If I set all these terms to 0, I would have this term as 0. This term is also changed to be 0. This term is also being 0, and our last dg would be 0. So the remaining formula would look like dy is equal to 1 over 1 minus c1 minus b1 multiplied by minus b2 di. As I have said, our intention now is to calculate the slope of IS curve, and the slope of IS curve is normally written as the di over dy. So we would like to find out what di over dy is, depending on the formula that we have just derived. So when we convert this equation into di over dy, this would basically give us this would give us 1 minus c1 minus b1 divided by b2, and this whole term is a minus. So this is again a slope of our IS curve. This negative term indicates this should be less than 0 if and only if our c1 plus b1 is greater than 1. If c1 plus b1 is greater than 1, sorry, c1 plus b1 should be less than 1. So if our c1 plus b1 is greater than 1, our nominator term would be negative, and negative would cancel out with negative, so it would give us a positive value. When we are interpreting the slope of IS curve, we are saying it is less than 0, so long as c1 plus b1 is less than 1. The next item on 17.2 is interest rate responsiveness of investment. Interest rate responsiveness of investment is represented by the parameter b2 in our formula that we have just seen. So which value would the slope of the IS curve take if the interest rate responsiveness of investment, or b2, converges to 0? We have just said our slope of IS curve, which is given by di over dy, this IS is to indicate that, is equal to minus 1 minus c1 minus b1 over b2 is less than 0 if c1 plus b1 is less than 1. So we are trying to calculate the limit of our equation here. If b2 converges to 0, the limit of our 1 minus c1 minus b1 over b2. So if my b2 converges to 0, this would give me a value of minus infinity. So this is to say, if my b2 is converging to 0, not actually becoming 0, this number is becoming very, very less, and this is again pushing my number to, or pushing my entire value to a negative infinity. So if b2 is converging to 0, as we have just seen, there are two things that are happening immediately. The first thing to note here is the slope of IS curve will converge to negative infinity or minus infinity. And the second thing that we notice is that if the slope is converging to minus infinity, the IS curve is then vertical line instead of what we have been seeing so far, about the IS curve.